Morning students. In control and instrumentation lab, there are two parts. One is called as control system, another one is instrumentation. So in the last video, I have explained about the LVDT. Today I am going to explain about the instrumentation amplifier. So first, what is meant by amplifier? Amplifier is a circuit. It is used to convert weak signal into strong signal. There are various types of amplifiers are available. Example, non-inverting amplifier, inverting amplifier, summer, integrator, differential amplifier, like that various types of amplifiers are available. So each amplifier is used for some applications. So today I am going to explain about the instrumentation amplifier. So in instrumentation amplifier, I am using IC741 operation amplifier. So we need 3 operation amplifier. So 2 inputs you are going to give. One is called as an V1, another one is called as an V2. And we will get only one output, that is called as VO. So IC741 consists of 8 pins. 2 input pin, one is pin number 3, another one is called as 2, and 6 is the output. Next one is pin number 7, you have to give a 12 volt DC, another one is called as 4 is called as minus VC, you have to give. Number 3 is called as a non-inverting amplifier. If you give input to pin number 3, so you will get as a non-inverting output, and if you give input at pin number 2, you will get as inverting amplifier. First, you have to find out the voltage gain. So we are connected the various resistance R3, R2, R1 and RG. Based on that, you have to calculate the formula that is called as voltage gain. So this is the formula 1 plus 2R1 divided by RG into R3 by R2. So this is the main thing. So voltage gain is the main thing. For example, now my voltage gain is 10. So what is the output voltage? V out is equal to A into V2 minus V1. Assume that voltage gain is 10. So example, you take V2 is equal to 20. V1 is equal to 10. So 20 minus 10 is nothing but 10. 10 into 10, you will get as 100 volt. That is the output voltage. Next one, the instrumentation amplifier. The other name of the instrumentation amplifier is called as data amplifier or difference amplifier. So it is used for various applications, for example, testing, measuring, recording applications, or it is used to control other parts of the system, or it is used to operate other parts of the system. Next one is, for example, if you take any sensor, pressure sensor, the output will is very weak signal. If you want to do any processing, it is very difficult. So you are going to convert that low level signal into high level signal. Next, all the signals will be interrupted by using the noise and atmospheric interference. So here the instrumentation amplifier is less affected by the interference, atmospheric interference and noise. Next, for example, I want to measure the temperature, boiler temperature. So it is in some one place and your control room is another place. So from the sensor is placed in the boiler. So the sensor output is connected to the control room through the large cables. So what we have to do, we have to convert into high signal. So it is a special amplifier. It has lot of features are available. So these are some features of instrumentation amplifier. High CMRR, low power consumption, low input impedance and high input impedance and low output impedance. If you take any amplifier, so the output impedance should be very less, input impedance should be high. So only what means the voltage gain will be high, so we can amplify the signals. So the amplification factor will be very high. Next one is as high slew rate, low thermal and time trips. We can adjust the gain easily by changing the resistance value. Finite, accurate and stable gain. Always the stable gain value is constant. These are some features already you have studied in the previous LSC subject also. Next, we are going to see some applications. So there are various types of applications this instrumentation amplifier is used. I have listed few applications. One is it is used for temperature controller. To take the boiler temperature you have to control means we can use this instrumentation amplifier for indicating the temperature. Next, light intensity meter. If you want to measure the intensity of the light, you can use instrumentation amplifier. To measure the physical quantity, we can measure the weight machine, humidity measurement, pressure measurement, measurement of flow level, water flow, liquid flow, gas flow. All these things we can use this instrumentation amplifier. Mainly in lot of industries, we are using this instrumentation amplifier. Example, dairy plant, sugar plant, furnaces, etc. All these you are using this instrumentation amplifier. So the temperature. So there are four arms are there. This is called as a Wheatstone bridge, and this is called as operation instrumentation amplifier. So here we are connecting the sensor. Any sensor we can connect. Pressure, humidity, displacement. Next one is load, etc. Any types of sensor we can use. So here we take the RTD. So what will happen means, depend upon the temperature, the resistance value will change. When the resistance value change, automatically the output voltage will change. So that is given to the instrumentation amplifier. So we will get then change in output. So if there is a low resistance, automatically based on that voltage will change. So output voltage also change. The temperature increases, the resistance will get changes. When the resistance change, this voltage will VAB change. When the VAB change, automatically the output voltage will change. This is called as temperature. Suppose you want to measure the weight. For that, load cell is available. In load cell, there is called as strain gauge is used. So when you apply the pressure, automatically the resistance value will get changed. When the resistance value gets changed, automatically the VAB voltage change. VAB voltage changes, output voltage will change. So like this, you can measure for weighing machine or load cell. Next, if you want to measure the intensity of the light, so we can use some LDR. So LDR, what it means, input is light, output is the resistance value will change. That is called as LDR or photo cell. So when there is some change in light, automatically the resistance value change. Resistance value change means the VAB voltage will change. That is given to the input of the instrumentation amplifier, and we will get the output. So here you have to change, depend upon the applications, you have to change this arm. So these are about the instrumentation amplifier. So I am going to design the instrumentation amplifier circuit. First select the components. So for that, click this. These are the buttons available. So using these buttons, we can select the components. First one is called as a component mode. Click the component mode. Next, click this P. So it will ask the keywords and we can select the components. Now I am going to type first IC741 amplifier. So this is called as IC741 amplifier. Click and paste it here. We need 3 op-amp. So I have placed 3 op-amp. Next I need some resistance. So type RES. So we need some 3, 5, 7 resistance. Rotate this resistance in anti-clockwise. Select and right click. arrange this resistance. Next, we are going to give the supply. For that, we need a power supply, and we are going to select the part. First one is, so this part is, it is used to vary the input voltage. We need two part because we are going to give two inputs. So the inputs are connected to the positive. Both the inputs are connected to the positive. Next, I am going to give the power supply of 5 volt. For that, this is a terminal mode. Click the power. This is called as power supply. So power supply I am giving to the part. So IC 741, the 7 is called as plus BC. So connected to this power. Next, this is called as ground. Connect the ground here. Next, first input V1 is given to the pin number 3. Second, V2 is connected to the pin number 3. Next, 2 is pin number 2 is connected to this. Connected to the resistance. Next, pin number 6 is connected to this resistance. 3 is connected to and 2 is connected to pin number 2 is connected. This 3 is next you have to give the 3 op amp is there. 3 op amp. I'm going to give the minus 5 volt. For that, select components, DC supply or voltage. Select the source. Select the voltage source. Connect to the pin number connect to pin number 4. Pin number 2 and 3 is input, 6 is output, 4 is minus V volt, and 7 is plus 5 volt. Select the ground pin. Select ground pin. So you have to give the minus 5 volt. So double click, give minus 5. And minus 5. So now I have to measure the input and output. For that, I need a voltmeter. Go to virtual terminal. So DC voltmeter. 3 voltmeters. One is for output, one is for 2 for input. Connect the ground pin. Double click this voltmeter. So the range gives a millivolt. You click OK button. Here also millivolt. Now change the resistance value. 10 ohm, 5 ohm. This is called as 10 kilo ohm, and this is 10 kilo ohm, and this is called as 5 kilo ohm. Next, these two resistance are 1 kilo ohm. Next, this is called as 2 kilo ohm. change all the resistance value. Now the input is 100 millivolt. 100 millivolt into 10 is 1000 milliamps. That is nothing but 1 milliamps.